Hey everyone, welcome. Today we're going to tackle one of the most powerful tools in math, exponents. Now they might look a little intimidating at first, but they're actually a super simple, really elegant solution to a very common problem.
I mean, just imagine you're a mathematician, and you have to write out the same number multiplied by itself over and over and over again. It's tedious, it takes up a ton of space, and it's just not efficient. You'd have to think, there's gotta be a better way, right? Just take a look at this. It's a whole bunch of threes all multiplied together. Writing this out every single time would be a total pain. It's practically screaming for a shortcut, some kind of elegant solution. And boom, here it is. This one, compact, little expression says the exact same thing as that long string of numbers we just saw. This is an exponent, and it's the beautiful shorthand we were looking for. So, what do these numbers actually mean? In this first section, we're going to break down the notation and really see how this powerful shorthand actually works. You know, at its core, the definition is pretty simple. An exponent is really just an instruction. It tells you exactly how many times to multiply the main number, which we call the base, by itself. That's the key. It's all about repeated multiplication. This slide lays out the two key parts perfectly. In the expression 3 to the fourth power, that big number, the 3, is our base. That's the number getting multiplied. And the small number, up top, the 4, that's the exponent. You can kind of think of it as the boss, telling the base how many times it needs to show up for the multiplication party. And here's where it all comes together. 3 to the fourth power just means we multiply 3 by itself 4 times. So let's do it. 3 times 3 is 9, times 3 is 27, and times 3 one more time is 81. Simple as that. Now that we've got the basics, let's check out a few special cases. All right, now that we have the fundamentals down, let's look at a few special rules and names that'll make working with exponents even easier. Honestly, these are the little details that will make you sound like a total pro. Okay, two really important rules here. First, any number to the power of 1 is just itself. That makes sense, right? You just write the number down once. The second one, though, is a little strange, but it's absolutely crucial. Any non-zero number to the power of 0 is always 1. Yep, not 0, 1. It's a fundamental rule in math, so just go ahead and lock that one away in your brain. Now, when you see a number with a little 2 as the exponent, we have a special name for it, squared. And this comes from geometry. If you have a square and its sides have a length of, say, a, its area is a times a. This geometric connection is foundational in so many fields, like physics and engineering, where you're calculating area all the time. And in the same way, when the exponent is a 3, we call it cubed. Again, think geometry. The volume of a cube is a times a times a. It's this link to 3D space that makes cubing essential for everything from architecture to 3D modeling. It's pretty cool how the language of math is so connected to physical shapes, isn't it? All right, let's take a minute to talk about the single most common mistake people make when they're first learning about exponents. Getting this right is absolutely the key to mastering this whole concept, so pay close attention. The trap is so tempting, right? You see 3 squared, and your brain wants to just multiply the base by the exponent. 3 times 2 is 6. But that is completely wrong. You have to remember, the exponent of 2 tells us to multiply the base, 3, times itself. So it's 3 times 3, which equals 9. As you can see, it's a completely different answer. So the crucial point is really this. You have to always remember that exponents are about repeated multiplication. They are not a simple shortcut for multiplying the base and the exponent together. If you can remember that one rule, you've avoided the number one pitfall for sure. Okay, so we know how they work. But why does any of this actually matter? Let's connect this abstract math concept to the real world, where you actually see exponents in action all the time. Exponents are seriously everywhere. The storage on your phone is measured in gigabytes. That's all based on powers of 2. We've already talked about how area and volume are measured in units squared and cubed, but maybe the most powerful application is how exponents describe anything that grows really, really fast, from the compound interest on your savings to how quickly a video can go viral online. Take a look at how this growth works. 2 to the first power is just 2. Okay, then 2 squared jumps up to 4. 2 cubed is already at 8. Now, while these numbers might not seem that big at first, each step is doubling the last one.
This is the very beginning of exponential growth, a process that can get unbelievably big, unbelievably fast.
So, I'll leave you with this question to think about. This explosive power of repeated multiplication is a pattern that shows up everywhere, from technology to nature to finance. Now that you understand the language of exponents, where else in your world do you see this incredible pattern of explosive exponential growth?